A flask containing 20 centimeters cubed of dilute sulfuric acid H2SO4 of concentration 0.15 moles per dm cubed. 7.2.1, we'll leave that out since it's not such a difficult question. To obtain a final pH of 12.96, a learner adds 30 centimeters cubed of dilute sodium hydroxide NaOH of concentration 0.25 moles per dm cubed to the flask according to the following balanced equation. An unknown volume of dilute barium hydroxide of concentration 0.1 moles per dm cubed is then added to the flask to obtain a pH of 12.96. Assume that the volumes are additive and that both sodium hydroxide NaOH and barium hydroxide BaOH2 are strong bases. Question 7.2.2, calculate the volume of barium hydroxide that was added. So before we actually start the solution, there's some things that we need to take care of before. So H2SO4 is diprotic, meaning that the concentration of the H3O plus is going to be double the concentration of the H2SO4. The NaOH is monoprotic. So the concentration of the OH minus is going to equal the concentration of the NaOH. And then lastly, barium hydroxide, BaOH2, that's diprotic, meaning the concentration of the OH minus is going to equal 2 times the concentration of the barium hydroxide. Now that we've taken care of that, I think let's go ahead and actually start the solution. It's 8 marks, so it's going to be quite involved. So the first thing I want to do here is I want to just draw a diagram just to make it a bit easier to understand what's going on. So if we have some container of some sort, and in that container, we've got 20 centimeters cubed of H2SO4, and the concentration of that H2SO4 is 0.15. Then they've added in some base. So they tell us 30 centimeters cubed of NaOH, and the concentration of the NaOH is equal to 0.25. And then lastly, they add X amount, so X cm cubed of barium hydroxide. And the concentration of the barium hydroxide is 0.1 moles per dm cubed. And we know that the final pH, after all of these things were added in, is 12.96. So the first thing we got to do is we got to examine the pH. So the pH is 12.96, which means it's basic, right? And if it's basic, it means that there's excess OH minus in the solution, right? So there's excess OH minus in the solution. So let's go ahead and start with some calculations. So the first thing we want to do is we want to calculate the number of moles of H plus that's coming from the H2SO4. Now, as we said before, it's going to be 2 times the concentration of H2SO4. So 2 times concentration times volume. And this is going to give me the number of moles. So 0.02. And that gives me 0.006 moles of H plus. Next, we can go ahead and calculate the number of moles of OH minus that came from the NaOH. Now, because NaOH is monoprotic, it's going to be the same. So 1 times the concentration, 0.25, multiplied by volume, 0.03. And that's going to give us an answer of 0.0075 moles of OH minus. Now for neutralization, the number of moles of OH minus and number of moles of H plus will equal, right? But as you can see here, there's going to be some extra OH minus. So what we can do here is we can say the extra OH minus is going to equal 0.0075 minus the OH minus that would have been needed to neutralize the H plus, so minus 0,006, and that's going to give me 0,0015 moles of OH minus. So that's even before the barium hydroxide was added in. Now let's consider the barium hydroxide. So barium hydroxide was added. So I'm going to put this in a different color. So the number of moles of OH minus that has come from the barium hydroxide is going to equal 2 times, remember barium hydroxide is diprotic. So 2 times the concentration, so 2 times 0.1 times X. Now X, remember, that's Cm cubed, we have to convert to dm cubed, so X over 1,000. We can simplify here. This is going to give me 0, so this is going to be 0,2 divided by 1,000, so that's going to be 0,0002 X moles of OH minus. Now this number of moles is going to be added with that number of moles, and we're going to have a new total extra number of moles of OH minus. So the new final excess OH minus is simply going to be 0,0015 plus that of the barium hydroxide, so 0.0002 X moles. That's the first part taken care of. So we're going to keep this, we're going to need this. Now the second part, let us look at the pH. So we know that pH plus pOH is equal to 14. So pOH is going to equal 14 minus the 12,96. Now the reason why we're using the pOH is because we know that we have excess OH minus. So pOH is going to equal 1.04. Now from here we can calculate the concentration of the OH minus that's in excess. So pOH is equal to minus log the concentration of OH minus. So 1.04 is equal to minus log the concentration of OH minus. So the concentration of OH minus is thus equal to 0,0912 moles per dm cubed. Now we can take this right here, and we can take this right here to form our final new equation that we can use to solve for X. So let's join that up, and we can use the formula concentration is equal to number of moles divided by volume. So 0,0912 is equal to the moles, so 0,0015 plus 0,0002x divided by, and what's the volume? All of the OH minus is sitting in what volume? It is sitting in a volume of 20 plus 30 plus x. So it's sitting in a volume of 50 plus x, and don't forget that needs to be converted to dm cubed, so divided by 1,000. And now we can solve for x. X is going to equal 28.13 centimeters cubed.